Assalamu alaikum. So today we'll present our chat application, which is TeleCrypt. Let's start directly with the user flow, the user registration. So as you can see, the registration start by clicking on register, enter a username and an email. Then click continue. You will receive an OTP password to verify your account. Then you enter a password that comply with the LUD, the LUD if you want. Then a description and a date of birth. Here is it, and then you have created your account. I have another user right here, so we will you will send a request to chat with this person, add a friend. So it's called Joe. You will send him a request and he will receive it in real time. He will choose either to accept or reject your invitation. So let's accept it. And here you will start chatting, as you can see, in real time. You can also send encrypted files. For example, this file. Also, you can send voice messages. Test. And the message will be sent encrypted. Test. As you can see, here this key here is to refresh the key of decryption. That is, you will initialize another Diffie-Hellman with the same with the person that you are talking to, so as to have the same shared key. Also, if we enter to the same account that is on my phone here, as you can see here, we have paired the two devices. Now you can decrypt the messages from both sides. Now let's go talk about the technical part. Now let's go to the technical part. So after the user create an account, he will search for someone to send him a request for chat. If that person accept the request, a Diffie-Hellman, it will be applied between them. The Diffie-Hellman was created from scratch. They will generate the A and the B and share, as we have studied in the course. So we have a very robust architecture right here. So we have the RSA AES in the encryption. We have also an encrypted storage for the local storage, the SQLite that is in the phone. We have the Diffie-Hellman for the user management. We have also enforce HTTPS plus certificate pinning, and for session management we have a device pairing. So it will be explained. Okay, so for the encryption of the messages, we have used AES with the CBC. So for the encryption algorithm used in message, we have used an AES CBC, which is a very robust encryption algorithm that uses mathematical method to generate random numbers with a very high entropy. And also we have this initialization vector that will be XORed with the first block of the data And also we have the PKC7 for padding to ensure messages that can be that can have any length, because as we know the chat messages can have any length. So also this is the encryption flow. So the device file, if for example Alice, encrypt the message, send it to the server. Server cannot know what the message contains. Even the server itself, as you can see here in the Supabase, the messages are encrypted, as you can see here. Even the files are encrypted. Here they are. Even the files are encrypted. We have used, as I was explaining, a secure random number generator that uses the Fortuna algorithm. Also, to avoid the man-in-the-middle attack, we have used a concept called certificate pinning, where we pin the certificate in the device itself, so no one can pretend to be the server. In the device pairing algorithm, so the first thing first, the device A generate a unique pairing ID with 5-minute expiration. Then the apps schedule automatic cleanup timer for security. The new device detect the device pairing request. Then the device B will generate an RSA to the 2048 key pair. The device B will send its public key to the device number 1, the public key. So the device number 1 will grab all the data along with the private key used in encryption of the messages, and will wrap it with the public key of this device, and also he will sign it with its private key. So when the package arrives to the device number 2, he will verify that it is from the device number 1, because it is signed with the key of the device number 1, and also he will decrypt the packages using his own private key, and then he will be authenticated, so both devices can be used for chatting. Also, another concept that we have used, which called automatic key rotation. So if each 30 days the two devices will. Also another concept, which is the automatic key rotation. So each 30 days the key that is used in Diffie-Hellman will be regenerated. So we will generate a new key that will be shared between the two devices. This process will be done automatically. So it will be done automatically each 30 days without the knowing of the end users. As I have said before, we have used a secure storage. We have used the secure storage for. We didn't use the shared preferences or the packages that are well known in Flutter. We have used secure storage, which will encrypt everything that is in the local database, and in the back end we have enforced the HTTPS with the TLS 1.2 and above. Thank you for listening, and that's all.